First, let me know who are present here. This is the operation research, and operation research itself is now considered as a subject, and in many university, many colleges and the institutes that was open as a subject. And there are lots of research also, and very applicable, very useful topic also. See, in almost all the companies, I have to say, almost all the company or almost planning of um, all the planning of every each and every government, this optimization is required. And how this problem is started, or it was created, it was born, is that it is during the Second World War. During the Second World War, the war is everywhere, and Manipur is also one of the important part. I think all of you had already came to NIT Manipur during your first year.
Yes, sir.
Yeah. Then I think you had done only the midterm exam, and after that you cannot come to NIT Manipur. Is it so?
Yes, sir.
Yeah. But you are at least somewhat lucky. But your junior base, they never come here. They had already completed 1 year. And then this next base also, first year they have to do online class. In Manipur, the war is affected in almost all the parts of Imphal Valley, and then Moirang is one of the important place. It is the battleground between the British Army and Japanese Army. And the point is that during that war, everywhere it is war. In Europe, all the countries are under war, and then in the Asia also, in the America also, everywhere, in Africa also. And then for the British Army, what they have to do is that they have to face the war in many parts, in Europe as well as in Asia. Say, like in England also, they are fighting the German forces, and in Manipur they are fighting the Japanese forces. And that is why some management is necessary. Say, during the war in Imphal also, at the very beginning, Japanese army took control of the whole of the Manipur. Japanese army, they came with the Indian National Army, INA, under Netaji Subhas, and then most of the portion of Imphal they had already captured. And then later on, British regain it again. And how it is done is that, see, for Japanese army, 3 columns of army is coming to Manipur in order to conquer Manipur and going further to other parts of India. But British army, they are arranging 4 column. And earlier it was not so. Many armies are collected from other parts of the other parts, and they are fighting with 4 columns. And that is why ultimately they won. So such type of arrangement is necessary. And that is why, due to that, I think maybe some other factor also, at the end, British army can regain Imphal again, reoccupied. But how it is that, see, war is everywhere. What are the requirements for war? Army is required, and then vehicles are required, foods are required for the army, and then ammunitions, the arms and ammunitions are also required. And how it is to be managed? Say, suppose in one area only 100 army is there and 500 the arms are there, then what is the use of that? 400 are not used. But say in some area only say 1000 army is there, only 500 arms are there, then how they have to manage? And these things may happen, and that is why in order to manage it, this problem started, and that is called optimization. Optimization means maximum use, or the say it is better to know well from the company things. See, for example, let us take up for a company. In the company, their main target is to get the maximum profit. In order to get the maximum profit, they would like to make they would like to use efficiently all the stuff. That means they would like to work with minimum staff and maximum product to get the maximum profit. And how it is to manage, say suppose 3 people are there, only 2 are working, 1 is not working, he is sitting always because he has no work. If it is so in a company, then his salary will go, then how company will get the profit? That must not be happen, and that is why they have to manage it. And in order to manage it, this problem started. And already I think regarding the linear programming, you had already studied in your class 11 and 12. Is not it? Have you heard about linear programming in
Yes,
your
sir,
class
little
11, 12?
little bit in 12th.
A little bit. You had done graphical method, and you have done some problem solving also. See, in the graphical method, that is the one of the easiest way. But the problem is that graphical method, it is possible only for 2 dimension. Is not it? In order to draw the graph, 2 dimension is the only possible. 3 dimension is not possible in your notebook. And 2 dimension means only 2 variable. 3 dimension means 3 variable. 4 dimension means 4 variable. Then more dimension will come, 5 variable, 6 variable, 7 variable. Up to 2 dimension you had done. 2 variable you had done either graphical method or some other method. And now that is the stage for the school level. And now you are in the graduate level, engineering graduate. Then in this case, more variable will be necessary, more bigger problem will be necessary, and that is why for that one method of solution that is called simplex method will come here. And simplex is the method which can solve for any number of variable and any number of say any type of problem. So for example, see, in a company only 2 staff is there. Then in order to get the in order to solve the optimization problem, you can manage with the graphical method. But company with only 2 staff or company with only 2 machine, that may not be feasible. Company may require many staff and many machines, and that is why ultimately more dimension is necessary, and simplest method is required here. How the problem start is that let me start with this. See, can you see this?
Yes, sir.
Okay, then let me start with this. See, see, you are asked to solve this problem. To solve this problem, see, here you have to find maximum of this. Maximum of this for x1 plus 12x2 plus 15x3 plus 2x4. And subject to the condition is that 2x1 plus 3x2 plus 5x3 plus 6x4 equal to 16, x1 plus 2x2 plus 2x3 plus 3x4 equal to 9. In order to get the maximum z, here we have to know the value of x1, x2, x3, x4. This value of x1, x2, x3 is to be solved from here. And it is also given that x1, x2, x3, x4 are all positive. Then the question comes, how it is possible? Can you solve this? By solving these 2 equations, can you find x1, x2, x3, x4? Normally, what we know is that number of variable should be equal to number of equation, is not it? Yes. But here, there are only 2 equations and 4 variables. Solving is not possible. But we make it possible in our case, and that type of solution we will consider here. And the condition here is that we have no option, but what the condition we have to use is that out of this 4 variable, we will make 2 0. Say for example, you can make x3 0, x4 0. Then if x3, x4 is 0, then this First equation will reduce to 2x1 plus 3x2 equal to 16. And second will reduce to x1 plus 2x2 equal to 9. And then you can find the value of x1 and x2. And that this is the solution. First solution is the solution. We put x3, we take x3 0, x4 0, and we find x1 5, x2 4. And similarly, by taking some other two variables, say for example x2 0, x4 0, also you can get x1 value of x1 and x3, like that you can do. That means in order to solve this 4 variable 2 equation, number of variable is 4 and number of equation is 2, and that type of solution generally we know that it is not solvable. But in order to make it solvable, we have to make some variable 0. How many variables we have to take 0 is that from the 4 variable you subtract the number of equation 2, then remaining is 4 minus 2 equal to 2. That 2 variable you have to make it 0. Suppose here we have 5 variables. We have 5 variables and 2 equation. Then 5 minus 2, that is 3. We have to make 3 variable 0. And then we can get the solution. Otherwise, we cannot get the solution. And such type of solution is called basic solution. Such type of solution is called basic solution. Then what can you say? What is meant by basic solution? I had demonstrated, but if you are asked what is meant by basic solution, then what I am saying that you can answer those solution obtained by making number of variable minus number of equation, by making the variables number of equation and number of variable minus number of equation 0. And that is called, that type of solution obtained in that case is called the basic solution. And then these are all basic solution. In the basic solution, see, here some values may be negative and some values may not be negative. And another thing here also, we will have a type of like this. X1, X4 does not exist. Oh. It is not in this case. Say suppose here in our case we are taking 2 variables 0, but solution we are getting non-zero. But in the solution itself also we may get some 0 also. Some 0 also. That type of solution is called another name is given to that equation solution also. And let us see from the definition now. See. First is the feasible region. Let me explain this. The space defined by the constraints in which all the constraints are satisfied is known as the feasible space or feasible region. Regarding the constraint and other thing I am not telling. I will explain here again. See. Here, this problem is what we call as the linear programming problem. In this linear programming problem, here it may be maximum of the value or minimum of the value. It may be either maximum or minimum. In our case, it is maximum. Maximum z we have to obtain. And here, maximum z or minimum z, that value of z, this is called the objective function. An objective function is to be obtained subject to some equation or inequation. This equation or inequation given is called constraint. And the variables are some restriction is given to the variable. That means x1, x2, x3, x4 should be positive or 0. This is called restricted variable. There may be unrestricted variable, and in this case restricted variable means they should be either 0 or positive, and unrestricted means no restriction is there. In that case the variable may be any value, may be positive, may be negative, any value, and those are called unrestricted. Okay, then let us come to this definition again. The space defined by the constraints. Constraint means this type of equation. Constraint in which all the constraints are satisfied is known as the feasible space or feasible region. See, you please remember the concept you have done, the problem you have done in your class 11 or 12. In your class at 11 or 12, for solving the linear programming problem, what do you do in the graphical method? You draw the graph of the given equations. And then with that graph, a bounded region is given, and that region is called the simply feasible region. It may be bounded or unbounded, but mostly we are considering bounded, and that region is called the feasible region. And feasible solution. A feasible solution is simply a point in the feasible region whose coordinates satisfy all the constraints, including the non-negativity restriction. That is the feasible solution. And then it comes to basic solution and basic variables. Given a system of m linear equations in n unknown, and here given a system of m linear equations in n unknowns, m should be less than n. M means what? Linear number of the m is number of equation, and n is unknown. In our case, value of m is 2. In the problem I had given, value of m is 2, and unknown n. In our case, n is 4, and that is why we have to take m less than n, and in our case it is 2 less than 4. The solution obtained by putting n minus m variables equal to 0 is called basic solution. Solution obtained by putting n minus m variables equal to 0 is called the basic solution. This is the same concept I explained you with the problem. In our problem, what we do? Number of variable is 4, number of equation is 2, we subtract, it becomes 2, that 2 variables we put 0, and after that we get the solution. The remaining m variables out of the n variables are called basic variables. Then degeneracy. Degeneracy is a basic solution. A basic solution is degenerate if one or it is or one or more of the basic variables become 0. One or more of the basic variables become 0, then that is called degenerate solution. Say suppose in our case we are taking 2 variables 0, and we are solving another 2 variable. While solving another 2 variable, one more variable may become 0, then number of solution with 0 will be 3 variable. In that case, the solution is called degenerate solution. And if it is only, in our case, if it is only 2 variables with 0 value, and that is called non-degenerate. Regarding the slack and surplus variable, I think it is better to explain later on, not at this moment, because we are not starting with the actual linear programming problem. Okay, these are the solutions, and here, and another thing is given here, we had given feasible, non-feasible. 2, 3, 6 are not feasible. 2 is not feasible. Why it is not feasible? Can you explain why 2 is not feasible? See, here we are taking x1, x2, x3, x4 positive, restricted. But here x3 is negative. And that is why this does not satisfy this condition. And that is why it becomes unfeasible. That means our feasible region will be in the first quadrant. But this point is not in the first quadrant. This is why it becomes unfeasible, and that point, this point will not be in the feasible region, and this also does not exist. Okay, 6 for this also it is negative, that is why not feasible. And 1, 4, 5 are basic, feasible, and degenerate solution. What is it? Whether my concept of degeneracy is long. A basic solution is degenerate if one or more of the basic variable becomes 0. The basic variable becomes 0. Degenerate 1, 4, 5, 1, 4. It should be non-degenerate, not degenerate. It should be non-degenerate because it is only with 2, 2, 0. No 3, 0 is there. 3, 0 should be degenerate. It is non-degenerate. It is my mistake. Okay. Then let us come to the linear programming problem now. See, let us see the model of a linear programming problem first. The general linear programming problem it will be like this. See, it may be either maximum or minimum z. Z will be C1 x1 plus C2 x2 plus up to Cn xn. We are using n variable, x1 to xn, n variable, and C1, C2 they will be numbers, and x1, x2 they are variables, where x1, x2, xn satisfy m linear equalities or inequalities, all the constraints of the form. See, this is the objective function. This is the objective function of the linear programming problem, and constraint will be like this. This is the first constraint, second constraint, third constraint, and this is the restriction to the variable. See here for the constraint, it may be less than or greater than or equal to. For this also same thing, may be less than, greater than, or equal to, but not all. It will be only one. It may be either less than, or it may be either greater than, or it may be either equal to. It will be out of this. But in order to solve the problem, according to this, mixing is possible, but we will reduce to the standard form. What will be the standard form, another thing that will come also. But linear programming problem will be like this. The same as we had mentioned here also, what I had mentioned here, it is maximum z. This is the objective function I already told you, and subject to constraint equation, two constraint equations are given, and then what we told in the general form is that it may be either less than or greater than or equal to. It is equal to here. This also may be either less than or equal to or greater than, but it is also equal to here. And this is the these are the constraints, and where one and only one of the sign less than, equal to, or greater than, equal to, or equal to holds for each constraint, but the sign may vary from constraint to constraint. And z is called the objective function. Thus the basic problem of linear programming is to find an extremum of a linear form in the feasible domain determined by a given system of linear equalities or inequalities. Then now, this is the general linear programming problem. Now we will come to the standard form. What is meant by the standard form? See, for standard form, this is not the standard form, this is the general form. For standard form, some characteristic is necessary. Let us see what are the characteristics, what are the properties it should obey by a standard form. The standard form of an LPP should have the following characteristic. Number one, all the constraints should be expressed as equations. See, like here in the example, constraint is written as equal. It should be like that. Okay, all the constraints should be expressed as equations by adding slack or surplus and or artificial variables. I need to give the definition of slack and surplus variable. Okay, let us discuss definition already there. The right hand side of each constraint should be made non-negative. If not, this is done by multiplying both sides of the resulting constraint by -1. Right hand side of each constraint. Right hand side means what? The side where only the constant is there, no variable is there. See, in our case, this is the right hand side. We are writing here b1, b2, they are constants. Okay, this is like this. This is the right hand side, 16, 9. Right hand side of each constant should be made non-negative. If not, it is done by multiplying both sides of the resulting constant by -1. The objective function should be the maximization type. The standard form of the LPP is expresses. Now let us write the standard form now. See, before writing this, you better to have the definition of this one, slack and surplus variable. With this, let us come to that point again. See here, in a linear programming problem, a slack variable is a non-negative variable added to the left side of the constant to make the inequality sign to equality. The surplus variable is a non-negative variable subtracted to the right side of the constant to make the inequality sign to equality. Both are positive, but one is to be added and another is to be subtracted. Why it is so? I will explain here now. Just suppose a linear programming is like with this xn and less than equal to. See, this left side less than the right hand side. Left side less than right hand side, but we want to make it equal in order to make it to the standard form. Then how this is made to be equal? See, their left side is less than the right side. If we add something on the left side, then something appropriate number on the left side, then that may be equal with the right side. It's not it. And that is why the variable is, some variable is to be added here. That variable added is called slack variable. Slack variable. And then say, suppose again in the contradictory, the concept, let us consider the greater than. If left side greater than the right side, we want to make it equal, then how we have to make it equal? Left side is greater. That means if we subtract something from the left side, then it may be equal. And that subtraction means what? Subtraction means
Addition to the right side.
deduction of a positive number. Is not it? Deduction of a positive number. And that is why subtracted a positive number. A positive number is subtracted. And that variable is called surplus variable. And one is slack variable, that is added. Another is surplus variable, that is subtracted. And both are positive. Slack as well as surplus are positive. And there is another one called artificial variable. Regarding that artificial variable, for the time being, we will not consider. Normally, artificial variable is associated with slack, the surplus variable, and that will come after this simplex problem. First, we will consider for the simplex problem only. In the simplex problem, you will consider only you will require only the slack variable. If case of surplus variable comes, artificial will come. Okay, those are the two variables. And then now see, say suppose an equation is like that, then the standard form will be like this. Maximum z, this is the objective function, it will be like this, plus see, originally we have only x1, x2 up to xn variable. In order to make it to the standard form, we may require this slack variable s1, s2, sn. And with this, we rewrite the objective function is like this. Objective function is up to this only, but we make the presence of this variable, and that is why 0s1 plus 0s2 plus 0sm, because they are to make it present but with zero value, and that is why the coefficients are all zero. And then here, say suppose it is earlier it is less than equal to, then by adding this slack variable we make it equality, and this is the slack variable. And next also same thing, let us consider as less than equal to, and we make it equal by adding slack variable s2. Similarly, slack variable sm, like that. Now number of variables will be x1, x2, xn up to the x1 to xn as well as s1 to sn. They are all positive, and this is the standard form. And in order to start our linear programming problem with simplex variable, first we will make it to the standard form, and after that we will start our problem. Is there any doubt, any the confusion? And if it is so, then you can ask me. And one more thing is that while starting with the simplex variable, you have to try to understand it very carefully. The thing is that some steps are there are some multiple steps are there. That is why those steps you have to remember. And another thing, regarding the calculation, it is simply the multiplication, division, subtraction, nothing others. But the thing is that you have to remember the steps, what is to be done. What are the first thing to be done, what are the second thing to be done, third, next, what are the things to be done, that you have to remember. Once you know the procedure, the algorithm, then everything will be easy. The calculation is simply what I told you. It is only the addition, subtraction, multiplication, division. But the thing is that what is to be done, that algorithm is important. Algorithm you have to remember. And I'll give you the full algorithm, but my suggestion is that you may not able to understand by reading all the algorithm. And over and above the algorithm, I will give you one problem, one solved problem with according to the algorithm by writing all the steps. And in the exam, you need not to do like that. Writing all the steps is not necessary. Only the calculated table is necessary. But at the beginning, I will give you the problem with all the which is done according to the algorithm. On that, I will explain you. And after that, we will calculate some more problem also. I'll take some more time here, some more days here in the simplex method, because once simplex method is known, then big M method also will be depend on the simplex method, and integer programming also will depend on simplex method. And that is why simplex is, to understand the simplex is more important. And normally for the simplex, questions normally comes in the exam also, and that is why it is very important. And but the thing is that it will be better for you to understand while I am teaching you. And then if you have confusion in that also, you can ask anytime. During the explanation also, I'll do slowly so that you may able to understand. And is there any question? If it is not, then let us stop here. And then I'll send you some more notes for the next class. And let us meet tomorrow again, same time. Okay,
Sir,
let us stop here.
excuse
Bye.
me, sir.
Yes. And tell me.
There was this request regarding this slot, like
Yeah.
if we continue to do the classes in the same way, like in the evening. That's causing me a lot of problem, right? Am I audible, sir?
Yes. Please tell me again. It is audible.
So like my internship time or slot, whatever you say, is colliding with the same you have taken this class time, right?
Internship time.
Yeah. So actually, I can't focus on anything. Like, what should I do?
Internship. Where are you doing? Where are you doing?
Sir, coding ninjas.
Okay.
Not just me. Like, most of my batchmates are doing the same, and they are facing the same problem.
Do you know my email address?
No, sir. Can you provide that in chat box?
Okay. I'll send you to that email address. All of you require write an application to me that you have such things, and then after that, after discussing with the other.
Sir, I was just saying, can you take class on normal routine? Because on that time I would be available.
Normal routine is not this your normal routine?
No, sir. Actually, your class is from let's
Sir,
see.
11 to 12, I think your class.
Yeah.
in
Your
the
class
morning.
is
11 to
scheduled to
12.
be yes, sir. 11 to
But
12
they are
in the
given
morning.
timetable 4 to 5.
I don't know what timetable they are following. They have given us different timetables.
See, our head of department is given the timetable for me 4 to 5. That is why I'm taking here. But if it is 11 to 12, then I have to take at the time.
Oh, yes, sir.
Yes,
That's
sir.
our request.
11 to 12 would be
Okay.
better for us.
First, I will consult. I will see. I'll ask to my head of department also. But okay, if it is confirmed, then
So should I
okay.
should I
At
send the
latest by
routine?
next week, I will try to change it.
Okay, should I send the routine in the WhatsApp group we have?
Yeah. You also send the time the routine. But the thing is that your head of department is not acting. He should send it.
Yes,
See,
sir.
even
There is a problem.
your list of students is not sending. That is why I cannot start the class in time. And same thing, timetable also not sending to me. See, you are in CSE. What is happening in CSE, we cannot know because we also have our own department. We have lots of duty and lots of classes.
Yes,
And
sir.
that is why they have to inform us in the right time. Otherwise, it is very difficult. And one thing is that I cannot say whether I have class at 11 for my department or not. That's also I cannot say. I cannot decide. But say suppose if coincidence is there, then can we do from 12? Whether it will be difficult for you? 12. Is there any class from you for you?
Actually, one
No,
of
sir,
our men
almost
takes class at that time. Actually, we are blank.
in first half, sir, we
We are
can do
left with-
class.
Yeah. Anything
First
like
half,
10 to 11.
at what time you will finish for first half? You start from 9, then when
Yes,
it will
sir.
finish? When it will finish?
Sir, it's a different on different day. Like in Sunil Pandey sir takes on 9 to 10 and 10 to 11, sir. Bineshwar sir
Hey,
taking.
Sunil
And,
Pandey also have class.
yes, sir.
Yes, sir.
numerical
Actually, there are
methods.
2 matches this semester.
Oof, how it is keeping 2 maths in one semester? It should not be. Sunil Pandey, whether he is also taking according to the timetable or not?
Yes, sir.
Yes, sir,
He is
he's
taking
taking
according
on
to
the
the timetable, sir.
Timetable. Then,
Yes.
then the first you send the timetable. Otherwise, I cannot see.
Yeah, I've sent you on the group.
Okay. Then let us confirm everything in the WhatsApp group.
Okay, sir, sure.
Okay. Bye.